in this problem, what I want to do is go over how to solve an acceleration problem in physics class. This problem should be in your note packet. It says Marissa's car accelerates at a rate of 2.6 meters per second squared. How long does it take for Marissa's car to accelerate from a speed of 25 meters per second to a speed of 32 meters per second? As always, we start by drawing a picture of what is going on. We have Marissa in her car, and that's moving down the road. Then we write down what it is that we know. So we look for our numbers. We have 2.6 meters per second squared. We have 25 meters per second. And we have 32 meters per second. Now, not only do we want to write down the numbers, but we also want to write down what letters they represent. And this is very important that we label the letters because it will help us to decide what equation to use later on. So I'm looking at my problem, and I want to look at words before it, which will help me to understand what it's representing. So it says that she accelerates at a rate of 2.6 meters per second squared. So that means that it represents her acceleration, and so that is represented by the letter A. When we look at the 25 meters per second, we look at the words before it, it says a speed of 25 meters per second. And the letter for speed that we are using is the letter V. Speed and velocity are going to use the same letter. And then I see the 32 meters per second, and it also says a speed of. So I'm going to again use the letter V. Now I have two speeds, and I have to distinguish one speed from the other. The way that I do that is this 25 is our starting speed because it says from a speed of 25. To show that it's our starting or initial speed, we use a subscript, the little letter I for initial. So that is our initial velocity or initial speed of 25 meters per second. It says it moves to a speed of 32 meters per second. So that means that it's our ending speed or final. To designate that it's our ending speed, we're going to use the subscript F. Which is again just a little letter beside it, just representing that it's the final instead of the initial. The next thing we want to do is we want to write down what it is that we're looking for, what we're trying to find, what letter. And it asks, how long does it take for Marissa's car to accelerate from a speed of 25 to a speed of 32? When it asks how long, like how long does it take you to get to school, what it's really asking for is how much time. So the words how long represent a time, versus words like how far, which would represent a distance. If I say how far do you travel to get to school, that would be looking for a distance. So now I have the letters that I know and the letters that I'm trying to find. So we have A, VI, VF, and T. What we're going to do is look for an equation that has those four letters in it. So here's my options. Now one of the imperative things is it must have, of course, the letter T, what we're trying to find. The first three equations have the letter T in it, but the last equation does not have T anywhere in it, so that one is automatically out. Then we go through one by one and see, do we have the other letters? So letter VF, that's our final speed. That was 32, so we know that in this first equation. Then I go to the next letter VI. Well, that was 25, so we also know that number in this equation. The last letter in this equation is A, which was 2.6, so we also know that letter, and therefore this is the equation we want to use, the first one. To show you why the other equations don't work, we can again go one by one and see, do we know it? For example, this second equation, we don't know the letter X. So right away, that eliminates that formula. Same thing with the third equation, we don't know the letter X. So that automatically eliminates that formula. Next step is we write down which formula we're using out of the 4. And the next step is to substitute our numbers. We're going to put in that 32 is equal to 25 plus 2.6 times t. Whenever solving here these formulas, the first step is to move everything that is not attached to the variable to the other side. So this 25 is not attached to my variable t. So I'm going to move that to the other side by subtracting it. I then get that 7 equals 2.6 times delta t. The next step is to remove anything multiplied or divided to the variable. Here we have 2.6 multiplied to it. So we're going to get rid of it by dividing by 2.6. The 2.6 cancels out on this side. And on the other side, when we divide, we get 2.7 for an answer. The last thing we need is units. In this case, it's a time, so the units is seconds. We put a box or circle our answer. So we have all of our steps. We have our givens and picture. We have what letter we're looking for, what equation we're using. We have our number substituted in, and then our answer with our units. Again, just make sure that you write down what letters each number represents, because that's going to really help you in figuring out which formula to use. We needed a formula with A, VI, VF, and T, and so we look for that